Hi, I'm Eddie Sangster and this is That Show. Now we welcome our new guest, Hannah Wakeford.
Hi.
So, Hannah, what is it that you do?
So I'm an astrophysicist at the University of Exeter.
All right. What do you teach there?
So I'm studying extrasolar planets, so planets outside of our solar system orbiting other stars. And what we do is we look at the atmospheres of these planets to try and kind of determine what the environment's like.
Oh, very interesting. And so I've heard some talk about solar flares, but me not being a sciencey man, unfortunately, I don't really know what a solar flare is. So what would you say to help me?
So there's these huge active regions on the sun called sunspots, and from these active regions you kind of get the emergence of magnetic fields from the inner sun that escape through the photosphere, the layer of the sun that we actually see. And these are kind of twisted field lines, and they're carrying huge amounts of energy from the inner sun. And when these reconnect, so when the two lines kind of twist over and reconnect together, that causes a release of a huge amount of energy. So it's kind of the equivalent of about 1 million hydrogen bombs. So it's a massive amount of energy being released at this one point on the sun. Right. So that causes the solar flares that we observe.
Oh, that's really interesting. It's quite worrying that we don't actually get told about it quite a lot, considering that seems like quite a substantial thing to obviously think about. Do other suns have solar flares?
Yeah, so our sun actually is quite a quiet star. It's got a really, really long kind of solar cycle. So every 11 years, the magnetic field of the sun kind of turns over from north to south. And this causes kind of different active regions to appear on the sun over that cycle. So ours is actually a really quiet star. We've actually done observations of other stars which are far more active. And there's actually one star called HD 189733. Great names, obviously. And this has got a planet that orbits it. And the NASA Swift telescope, so it's an X-ray telescope, it observed a solar flare going off on this sun. And then later, the Hubble Space Telescope observed the planet. And what they actually saw was part of the planet's atmosphere causing a tail behind the planet, because the solar flare had impacted the atmosphere so much, it had caused a lot of it to be lost. So these solar flares can have a huge effect. But this planet is actually about the size of Jupiter and about 8 times closer than Mercury is to the sun. So it's really, really close. So it actually got about 3 million times the effect on it than what we would get here at Earth.
All right. So does that mean that solar flares don't have any chance of hurting us as humans?
So the Earth's a fantastic place. I mean, we're able to live here, and that's because we've got this magnetic field around the Earth. And this protects us in a number of different ways, and it protects us from these solar flares. But it's if you go outside of the magnetic field of the Earth, that's when you start having problems. So these new missions to Mars that they're talking about, and the Apollo missions, which we kind of are learning from, that's when you've really got to think about the sun's effects and these solar flares, because if you're caught outside of the spacecraft, then you're going to get it's equivalent to radiation poisoning. So it can be dangerous, but we're actually protected very, very nicely here on Earth.
That's quite justifying. I've got to say, with the Apollo missions, you've said that obviously it's affected, but it's weird that as a member of the public myself, I've seen some of the movies and all of that, and they don't really portray anything about the solar flares or anything they had to worry about. It's all about landing on the moon, so it's kind of weird to think that there is more behind it than what they actually say. But yeah,
there's a lot of precautions in place. I mean, it takes 8 minutes for these solar flares to reach the Earth. They're traveling so fast. They're really high energy. They're so high energy, they're not actually in the visible wavelengths. We have to look in the X-rays and the gamma rays. And this means we can't look from inside the Earth. So we've got kind of satellites and observatories looking at them. But we've got an idea of when this activity is going on. And I mean, it's only if astronauts are perhaps caught outside the ISS, they've got to be really careful. But there's procedures in place for these kind of things.
8 minutes from the sun?
Yeah.
They must be travelling ridiculous pace.
They are, yeah, very, very fast.
Yeah.
It's the speed of light almost.
What was the biggest solar flare in history?
So the first solar flare event that was recorded was in 1859, and this was recorded by a UK astronomer, Richard Carrington, and he actually drew out all of his observations of the sun. So he was drawing out these sunspots, these active regions, and we've got kind of copies of the drawings that he made. And this was such a strong kind of solar flare event that it caused telegraph lines to spark and set fire to the telegraph paper that the operators were using at the time. So although it didn't kind of disrupt satellites, didn't have satellites in 1859, it caused some kind of really major events for the time, which is really, really interesting to see throughout our history. But there's a couple more recent ones. The 2003 solar flare kind of storm, we called it, occurred around Halloween. So it's called the Halloween sunstorm. This is my favorite one. I studied it when I was doing my undergraduate studies. And there were, over a 2-week period, there were 9 solar flares, and these were huge events. They were so strong that they actually kind of damaged the instruments in space that were observing them. So you can really see what strong effects this radiation has.
That's amazing, absolutely amazing. Well, that's really interesting. That's unfortunately all we have time for today. Thanks for watching. Good night.